All right, so we're given this fun little problem here with arrows and it looks like dimensions. Determine the x and y components of each of the forces shown. Also, determine the resultant magnitude and resultant direction of the two forces shown. So let's go ahead and get to it. First of all we have is dimensions, no angles. So for us to begin, we need to break that into components. And the way we do that is if you have the NCEES reference handbook, all you're going to do is go to the mathematics section, and then you're going to scroll down here, and we can zoom in a little bit, and you'll see that sine of theta is equal to y over r, okay? And then cosine of theta is equal to x over r. So we just break that into the components here. So sine of this theta would be this portion over this portion. Also, we know that tangent of theta is y over x, and that'll give us theta, but we have to use the inverse tangent, and we'll just go through that here in just a moment. So first of all, we have to establish a coordinate system. So we'll go ahead and break this into the x and y. On this particular problem, we wouldn't have needed to do that because the instructor's already done it for us. So you have your x and y, and this is your datum. So everything to the left or down is going to be negative. Everything to the right and up is going to be positive. Okay, so we'll go ahead and find theta 1 here. And the way we do that is we take the inverse tangent of 75 over 40, and that'll give us theta 1. And then to find theta 2, we do the same thing. We do y over x, and that'll give us our theta 2. Now we have to solve for the forces in the x direction. Okay, remember everything to the left would be negative, so this right here is going to be negative 340 newtons times cosine theta 1. This is going to be to the right. That'll be 255 newtons times cosine theta 2. And this right here is our answer. And then for the y direction, everything's up, so everything's going to be positive, except we use the sign because we've broken this into the components. We want this portion of the vector only. Okay, to find the magnitude, all we're going to do is find sum of the squares. So sum of the squares would be x squared times y squared square root of, and that's our answer, 425 newtons. And then we have to give it a direction. What direction is this guy going? If you're ever going to go into FEA, you'll have to describe to your boss or your colleagues if it's in shear or if it's in tension. What kind of stress is this thing going to be experiencing? And that's our direction. You will have to describe this graphically. Some instructors want you to do it graphically, but it's good to just understand what's going on. To the right, it's 65 newtons, up 420 newtons, and then the angle that it makes, or the magnitude that it makes, is going to be 425 newtons with an angle of 81.2 degrees. All right, that's it. That was your answer. Thank you for watching. Hope you have a fantastic day. Don't forget to like and subscribe.